All right, another analytic geometry video. This one's on finding the coordinates of the midpoint on a line segment or finding one of the endpoints. Let's have a look at that. Now, finding the coordinates of the midpoint of a line segment is pretty straightforward, although this formula might suggest otherwise. But all we're looking for here are the x and y values, the coordinates of a point that lies exactly halfway between two others. Now, to know that we would have to use the midpoint formula, they might use that word midpoint outright, or they might say a point that's located halfway between two others, or they might try to come up with something tricky, like if you left your house and someone else left their house and you walked towards each other in a straight line at the exact same speed, at what point would you meet? Well, you'd be meeting at the exact halfway point because you left and walked in a straight line at the exact same speed, so you'd be meeting at the exact halfway point. Now, using this formula, as with any other formula, you have to know what kind of answer you're looking for before you get started. Otherwise, you won't know what you're working towards. And here what we're looking for is a set of coordinates. So I'm going to need an answer for x and for y in my solution. So as we're working through this formula, we're going to have to keep x and y completely separate. And the comma is there to remind us that we're looking for a set of coordinates. It's also there to separate x from y and keep them separate. So I'm actually going to have two numbers in my answer. One of them for x and the other one for y. Now, first up here, this xm comma ym stands for x at the midpoint and y at the midpoint. That just reminds me what I'm looking for in this question. And I'm going to get those x1, y1, and x2, y2 values from my endpoints. Now I can label the endpoints x1, y1, and x2, y2 in any order, as long as x1 and y1 stay together in the same set of brackets, and x2 and y2 are labeled at the other endpoint in the other set of brackets. Now that I've plugged my numbers in for x1 and x2, y1 and y2 where they're supposed to go, I'm going to start calculating. But be careful here. I'm going to add x1 plus x2, press equals, and then divide by 2. And I'm going to do the same thing over on the y side. And then once I add up those top numbers and divide by 2, I've got a value for x and a value for y. And the midpoint formula is done. So keep the x value and the y value separate. Answer is a set of coordinates. And we're all wrapped up here. Now, it does get a little bit trickier. If they give us one endpoint and the midpoint, could we find the other endpoint of a line segment, just like we see in the question here? Now, we're actually using the exact same formula as we did to find the midpoint, but what we're going to do is write it a little bit differently. We're going to slide that xm and ym that represent x at the midpoint and y at the midpoint, we're going to slide those into the big set of brackets here. And to help us out here, we're actually going to call this one the endpoint formula. And even though it's done the same way, it's written a little bit differently and it's used for a different purpose. So we're going to write it separate from the midpoint formula. Now I'm going to go ahead and label my points. And remember, it doesn't matter which endpoint gets called x1 and y1 and which one gets called x2 and y2. And the xm, ym get labeled at the midpoint. Now that we've labeled this, we're good to go. Now, when I write out the endpoint formula, you're going to notice I kind of have two mini formulas in that big set of brackets. I've got one on the left side for x and then another one on the right side for y. And I'm going to make sure I keep those separate throughout the problem. Remember, my answer is a set of coordinates, one for x and one for y. Now I'm going to fill in all the values that I know that I've labeled in the question. Now notice I have two unknown values here, one on the x side and one on the y side. And that's what I'm trying to solve for in this question, that one unknown x value and that one unknown y value. Now to solve for those unknown values, I have to isolate them, right? That's how we solve for a variable. We isolate it or get it by itself. Now let's start on the x side. I'm going to show you what to do there, and then we're going to copy all those steps and repeat them on the y side with those different y values. Now the first thing I'm going to do is multiply by 2 to get rid of that divided by 2 around my variable. Now two things are important to remember here. One, don't forget I'm only multiplying by 2 to get rid of that divided by 2. So as soon as I write it on that side of equals, I can cross it out to cancel it. But because I multiplied by 2 just to cancel it out on that side of equals, I have to go ahead and multiply the other side by 2 as well. And now that I'm done that step, what I'm left with looks a heck of a lot easier here. So all I have to do is subtract that number to get the variable by itself. And remember to do it on both sides. Now that I've performed all those operations, what I'm left with is the x value for the endpoint that was missing. I'm going to go ahead and do the exact same thing on the y side to find the missing y value. Now lastly, if you wanted to, and this was a final exam, you probably should, you could go back and check your work by using the two endpoints to calculate the midpoint. And if you get the same answer for midpoint than what was given in the question, well, you know you did it right. Now watch these couple of examples, one on how to find the midpoint of a line segment and the other on how to find a missing endpoint.
Hey guys, this is the instructional for the midpoint formula. We'll get right to it here. Steve and Joni are having lunch out in the park. How sweet. When a water pipe bursts beneath them. Not so sweet. The explosion of water sends the two flying in equal distance in opposite directions. And I'll come back and refer to that language in a second. If Steve ends up at coordinates -3, 33, -33, -48, and Joni ends up at 1634, what were the coordinates of the exploding pipe? So, really the only tricky part here is understanding why this is a midpoint and what is it in the wording here that makes this a midpoint formula. So this is the key here, that the two fly in equal distance in opposite directions. So you can see that Joni flew this way, excuse me, a particular distance, and that distance is the same as the distance that Steve flew. So they both flew in opposite directions, the same distance. Because of that this distance is the same as this distance, that makes this, the point where they were eating where the pipe exploded, the midpoint. So that's my M right in there in case you couldn't quite make that out. And so really now we just have to apply the midpoint formula to the points that are here. And as usual, we're going to number these off, x1 and y1 and x2 and y2. And we'll write down that midpoint formula right away. Midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Really straightforward. I'm just going to caution you, to make sure you write down the formula correctly. For some reason, a lot of students love to put minuses in here. I think it has to do with the whole A formula, y2 minus y1 over x2 minus x1. But it's a common, I would call it more of a concentration error than an understanding error, but please make sure you copy that down correctly. Once you've got this and you've got your points labeled, it's really just a question of plugging in and solving. So x1 plus x2 is going to be, we'll open that bracket up, 16, right, for my x1, and -33, so plus -33, divided by 2, and then my y1, 34, plus -48 for my y2, divide that by 2. And those are our numbers all set up. So the calculator slides in here. And basically now I just got to crunch this. So 16 plus -33, or 16 minus 33, that comes to 17, -17, over 2, comma, and now I'll get the top part of this fraction over here, 34 plus -48, and that's going to come to -14. And that's divided by 2. I guess the last thing that maybe some students forget is they got to do that division. I mean, sometimes we just stop on the top. So make sure you finish it off. -17 divided by 2. So -17 divided by 2 is -8.5. And then -14 divided by 2, I don't need the calculator for that one, trust me on that, it's -7. So that point right there is the midpoint. This is where Steve and Joni were having lunch before that nasty water pipe blew them in opposite directions from each other, presumably ruining their lovely meal. Hey guys, we're doing midpoint backwards, otherwise known as finding an endpoint given one endpoint and the midpoint. So instead of being given the two endpoints and being asked for that middle like in the last question, you're being given an endpoint, traditional, given the midpoint and asked for the other endpoint. So if a line has a midpoint of 49, -10 right here, and an endpoint of 5, 6 right over here, what are the coordinates of the other endpoint B? So we're looking for that B over here. So we've asked you to tweak the formula for this a little bit, and I'm just going to write the formula down quickly, and you'll remember from the graphic that we slid that xm up into the equation here. So the middle x will always be equal to x1 plus x2 divided by 2, and that's the way we're going to calculate, or that's the formula we're going to use to calculate our endpoint. And then we'll put a comma in there, and then y middle is equal to y1 plus y2, also over 2. And so if we follow this formula in its two pieces, we'll work the x, and then we'll work the y, and then we'll kind of record our answers as we go down here. So I guess really the thing to remember is that this is my middle x. So I'm going to call that my xm, and I'm going to call that my ym. That's new notation for us. We haven't done that before. So those numbers are going to go here and here in each of those two formulas. If you think of just the x for a second, that x is going to go here. And that 5 over there, that'll slip in right here, and we're going to then find this x over here. It's actually much easier than it looks. This will be my x1, and this will be my y1. And then, of course, over here, these are the two things that I'm looking for, right? These are the other endpoints, or the other endpoint coordinates, x and y. So let's find the x first. So x middle is equal to x1 plus x2, whatever it is, divided by 2. So we know the middle x. The middle x is 49. So we write down 49 is equal to, and we know my x1, it's 5. Plus, now we don't know that x2, so I'll just leave it as x. And remember at the end, we got to divide by 2. So algebraically, what's bothering you probably here is the fraction. And a lot of students don't know what to do with this fraction. You got to get rid of this 2, but you can't just like erase it and pretend it didn't happen. It's there. We've got to deal with it. Can't just ignore it. So we'll remember our rules for isolating x, and I'll remind you that, you know, if that 2 is being multiplied to my x, if I had a 2x here, the way I'd get rid of the number in front of my x is to divide it, right? If the operation is a multiplication, we divide. If the operation is a an addition, we would subtract, right? Eventually we're going to subtract that 5. Well, what's happening with this 2? This 2 is being divided. It's it's a fraction, it's being divided, and the way to get rid of a division is to multiply. So what I'm actually going to do here, and I'll show this in red just to make it pop, is I'm going to take that whole thing and I'm going to multiply that by 2. And the only reason I'm multiplying that by 2 is to get rid of it, is to cancel it out. But whatever I do to one side of an equation, I must do to the other side of the equation. So I'm multiplying that 2 over there. Now, some of you may have learned the word cross multiplication, which is a shortcut. Really, what you're doing is you're taking that 2 and you're multiplying it over there. And it's going to work like that every single time. But algebraically, just so you understand it, you're really doing is multiplying both sides by 2. The result is the same. The result at the end of the day is going to be 49 times 2. So I'll bring the calculator in here, and we'll go 49 times 2, and we're going to get 98. So 98 is going to be equal to 5 plus x. So I've gotten rid of that bottom 2, the division, and now I'm just left with a nice subtraction to do. We're going to subtract 5 from both sides, and I'm going to be left with 93 is equal to x. So right away I can come down here and put that 93 in for the x. Of course, I still have to find the y, and to do that I've got to apply the middle y formula, and I think I have enough room here. So I'll go y middle is equal to y1 plus y2 divided by 2, and we're going to work the same way. We're going to find that y middle, that's your negative 10. And that's going to be equal to the y1, which is 6, plus the unknown y divided by 2. So just like last time, I'm going to ditch this division by multiplying. Right, so I'm going to multiply 2 there, and I'm going to multiply 2 over there. And that's going to give me negative 20 is equal to 6 plus y. I then subtract 6 from both sides, isolating that y, and I get negative 26 is equal to y, which is right there. So this number here is 93 negative 26. The big thing to remember is it's a slightly different formula when we're trying to find the endpoint, Make sure that the middle x gets plugged into the appropriate position and not into one of these two spaces. And then make sure you multiply by 2 in order to get rid of the bottom of that fraction, and then just do your subtraction afterwards. Same pattern every single time and you'll be good.